Hi, I'm Kelsey Brennan-Wessels, and welcome to this special edition of Earth from Space on the European Space Agency Web TV, the first high-resolution map of changes in Arctic sea ice thickness over the winter of 2010-2011 was recently revealed at an event at the Royal Society in London. The map was generated using data from ESA's ice mission Cryosat, which has been measuring the thickness of polar sea ice and monitoring changes in the ice sheets since its launch in April of 2010. At the event in London, I got the chance to speak with the Cryosat mission manager and the former Cryosat lead investigator. Let's take a look back to see what they had to say. With me at the Royal Society today, I have the honor of speaking with Tommaso Parinello, who is the Cryosat mission manager, and Duncan Wingham, who is the chief executive of the Natural Environment Research Council and the former Cryosat lead investigator. Hello, and thank you for joining us today. All right, now Tommaso, I want to begin with you. Can you start by telling me a bit about the Cryosat mission and what makes it so special?
Okay, thank you. Cryosat 2 is the third Earth Explorer mission, which has been launched into space and is already making and will make an important contribution to understanding how our planet's ice field are changing as a result of global warming. I would say it has two important mission objectives. The first is to measure the variational thickness of the sea ice in the Arctic, and the second one is to quantify the contribution of the melting of the ice in Greenland and Antarctica to the rise of the level of the sea. Now, Cryosat, I will say, it's important for and unique in many senses. For example, the first mission with an altimeter which is able to fly up to 88 degrees of latitude. It flies a sophisticated radar altimeter which is called SAR, and I think is a piece of a state of art which our European industry has been able to design and to implement. But probably what really makes important Cryosat is that the fact that today all the past and present missions have been able to give us a consolidated picture of the extensions of sea ice in the Arctic, but this yet is not complete, because what Cryosat is going to do is going to basically give a third dimension of this information. It's going to measure thickness, and this is quite difficult to do. And eventually, with thickness, we'll be able to change this and measure the volume of ice, which is changing between the years. Now, what at the Royal Society we have presented, I would say, the first map of the winter variation, and this is for us an important reference. And I guess in the following years, and I guess we could probably meet again next year, and we will show that time what has been the changes in thickness of the sea ice between years.
And of course, today was presented the first map of changes in sea ice thickness. Duncan, can you tell me a bit about what's so special about this map, and how is it useful to the scientific community?
I think you have to put the pictures that we show today in their historical context. Prior to Cryosat, what one had was very limited observations made from aircraft or submarines, which showed us what the thickness of ice was in limited areas of the Arctic Ocean and over short snippets of time. So we didn't have a synoptic, continuous picture of how the ice forms and how the ice declines. What's exciting about the measurements we've just shown is that first we now have a synoptic picture, so we can see the cycle of growth and the cycle of decay throughout the Arctic, and this allows us to unravel the extent to which changes in the ice are due to melting or thickening on the one hand, or due to the fact that the ice is being moved around by the wind on the other. You have very limited data in space and time, you can't unravel that. So what these data for the first time allow us to do is understand properly the role of the wind and the role of temperature in producing the variations that we see.
Now, Tommaso, of course, Cryosat has been in orbit for 2 years. What is the current status of the mission, and what does the future hold?
Well, as you said, Cryosat was launched about 2 years ago, and I immediately say that both the space and the ground segment are working very well. Now, immediately after the launch, we had 6 months of commissioning, which we tested and we validated all the elements of the ground and the space segment, in particular the instrument. And at the end of that 6 months, we knew that we had an instrument which was working beyond the initial expectation. Now, soon after that, we decided to release the data to the scientific community. This was a difficult, I'll say, decision to take at that time, because we knew that, and this is normal, that there were basically major faults. Probably there could have been major faults in the algorithm ground. So we decided to give it to the scientific community, knowing that, because we want to shorten the time to give them the possibility basically to discover these bugs. This was done, and also thanks to a number of expert team and all people also going in the Arctic, in Greenland, and doing in situ measurement. We have put all this together, we have solved these problems, and finally, I would say after 10 months, we managed to release a new set of data starting from February this year. And the next thing we have to do is now to reprocess all the data we have acquired so far, and I believe that in 1 year time we will have a large amount of data of excellent quality, and this will help us to achieve what we call the first mission objective, and see what is really how the thickness of the ice, not only the extension, is declining in the Arctic. So probably in 1 year time we could meet again and we could discuss about this.
And back to you, Duncan. Now, what expectations do you have for Cryosat data, and what would you like to see from the future of the mission?
I think in the Arctic we are performing the largest single geophysical experiment in oceanography that's ever been performed. We are gradually removing the ice cover by heating the atmosphere, and that allows the atmosphere to get to work on the ocean. That'll change the ocean circulation, first of all in the Arctic and then beyond. One of the nice things we've seen come from Cryosat is not simply the ice, but also the ocean, and from the ocean we can get its circulation. So I think Cryosat will play an absolutely unique role in coming to understand exactly how the ocean does spin up, how the wind does spin up the ocean, and how those changes in turn are propagated away from their source. I think that it won't be me actually who's making these discoveries anymore, but I do think that for all the young scientists out there, there's going to be a marvellous set of data with a very sweet scientific challenge, and I'm absolutely convinced that Cryosat will be a unique and marvellous mission.
Well, Duncan and Tommaso, thank you so much for taking the time to speak with us today, and we look forward to the future results from the Cryosat mission. And that brings us to the end of this special edition of Earth from Space. But remember that to find out more about space and about our planet, you can visit our website at www.esa.int. From the ESA Web TV studios, I'm Kelsey Brennan-Wessels.